Oh man, we've got an interesting bit in this video. So I wanted to include this because you've got those college professors out there and some high school teachers who want you to memorize the antiderivative of secant x and cosecant x. And here they are. The antiderivative of secant x is ln of secant x plus tangent x. And very much like secant x, the antiderivative of it is the negative, right? Just like the derivative of cosecant x has a negative. You got the negative, and you got the very same setup. But instead of secant and tan, you've got cosecant x plus cotangent x. So the question becomes, why is it that either one of these work? I'm going to show you why secant x works the way that it does. You don't need to know this, but this will at least help you to understand why it works. Otherwise, this video is just done to help those students who have those teachers that are like, yeah, you got to know the integrals of each of these. You don't need to know this for the A, B, or BC exam, however, and most teachers don't require this, but this course covers everything. So I'd be remiss if I didn't cover it. So how do you know that this equals this? This goes under the file marked. Who would think to do that? Well, it's pretty crazy. But what you do is you take secant x, right? And you multiply by secant x plus tangent x over secant x plus tangent x, which we are allowed to do because that is technically 1. It's technically the same value. And you might be like, yeah, really? Who? What? Why would you think to do that? Well, someone with a lot of time on their hands, obviously. Look what happens. When we distribute this in the numerator, because this technically is over 1, you get secant squared of x plus secant x tangent x. It's actually pretty nifty what happens here. All over secant x plus tangent x. And you might be like, yeah, so what? Well, check this out. The derivative of secant x is secant x tangent x. The derivative of tangent x is secant squared x. So therefore, if I let this equal to u, we're getting u prime up in the numerator. So u is equal to secant x plus tangent x. Du is equal to, now I'm going to write this in a different order. The derivative of tangent x is secant squared x. I don't want to get that confused. That's the derivative of tangent x plus the derivative of secant x is secant x tangent x. I'm doing it in that order so you see the direct substitution happening here. Now, secant squared x plus secant x tangent x is right there. Dx, that's du. Holy moly! Nice. The whole numerator is du. The denominator is u. What? Yeah, that's right. That's 1 over u, the integral of which is ln of the absolute value of u, which u was what? Secant x plus tangent x. Listen, you don't need to memorize why this works, but I wanted to show you just so that you saw where that formula comes from. A similar thing can be done here, multiplying top and bottom by cosecant x plus cotangent x, and it'll prove it. That's it. Know those if your teacher needs you to know them, or at least ask your teacher or professor if you're expected to know them, just so you're not caught off guard on a test. On the A, B, or BC exam, it will not be a part of that exam. I promise you. All right. I'll see you in the exercises in this section. Peace.